on behalf of the ICF. And I've been kind of in close contact with Course One and CDOT, trying to help facilitate this kind of bidirectional bridge, and really happy to see everyone here, really happy to be here with Web3 and a whole bunch of the people who will be using this bridge.
Billy?
Hi, I'm Billy. I work for both Interchain GmbH as well as the Interchain Foundation, doing mostly funding and grants proposal work. I'm on the board of management at the ICF, and also really excited to see everybody here. This is an extremely exciting proposal that's required quite a bit of coordination, and I'm really glad to see everybody coming together and working towards that.
Cool. Louis C. Dot.
Yeah, hello everyone. I'm Louis from CDOT, and CDOT is a developer team focused on blockchain interoperability area, and we're very happy to be part of this working group, and hopefully we can achieve some get some stuff done in this coordination mechanism. Yeah, thank you.
Cool. Philip Stanislaus.
Sure. Sorry, I had to switch on my video. Hi guys, I'm Philip. I'm based in Germany, Munich. I'm working with Snowfork and also with Centrifuge, which some of you might have heard. I have built blockchain applications on top of Substrate and on top of Cosmos, so I'm really excited to hear where this is going to, and I'm also
okay.
And excited to hear more.
Cool. Then Dominic from Intellect.
Hey guys. Hey, great to have us here, and thanks for organizing this call. I'm Dominic, I'm from Intellect, and we're building Polka BTC, so the Bitcoin to Polka dot and reverse bridge. And there's a bunch of others on the team.
Cool. Jazir Brooks.
Hey guys, I'm Jazir. I've worked with quite a few of you on different interoperability protocols on the Cosmos side, and then through Snowfork on the Polkadot side. Just here to see what the progress is like, and I hope to potentially do some additional applications again for both Cosmos and Web3 through various projects that I've got going on with some of you indirectly, and just here to be passive for now, but can share more details later.
Cool. We have a few different people joining from the Web3 Foundation. Maybe we can move over to their window.
I'm Peter. I'm on the Builder Outreach side at the foundation.
I'm Robert. I'm on the grants team.
David on the grants team as well.
I'm Alistair. I'm on the research team, trying to push bridging efforts at Web3.
Cool. Really nice to have you, Alistair. John Wu from CDOT.
Yeah, hello everyone. I'm John from CDOT, and we are, as Louis said, we are building IBC for Substrate, and very nice to see everyone here and also some old friends here. Yeah.
We also have Yuan Chao from CDOT.
Hello, my name is Yuan Chao. I'm a software architect of CDOT network, and I'm working on the implementation of IBC module for Substrate framework. Nice to meet you.
Cool. We have people from the band team joining. So Rabit, maybe quick intros.
Yeah, hi, I'm Soravit. So I'm the tech lead at Band Protocol. So basically, we are building a cross-chain decentralized Oracle. Right now, we have the solution on Cosmos, and looking forward to see how we can bring the data through IBC to Substrate world as well. So happy to give any feedback or contribute technically.
And hi guys, my name is Paul. I'm a CPU and co-founder at Band Protocol. So I lead pretty much a lot of integration at Band. So again, as Switch said, we are here to make sure that we can make the data available to the Polkadot ecosystem, right? And have a successful bridge from our blockchain, which is built on Cosmos SDK, over to the Polkadot.
Thomas from Parity.
Yep. Hello, my name is Tomasz. I work at Parity Technologies. And at Parity, we have a small team that is taking care of bridge efforts. And currently, we are building Ethereum proof of authority to Substrate bridge and Substrate to Substrate bridges.
Cool. Parth, Joe, and Brian and David from Chorus. Maybe Joe, we can give quick intros for all people from Chorus.
Put me on the spot. So I'm Joe from Chorus. I work initially as a platforms engineer and more lately as a software engineer. We have David also as a software engineer, and Parth, who I've been collaborating with on this this wormhole effort you'll see shortly, as also a software engineer. And I think Brian's also lurking in the background as well. Brian is our CEO. I think most of you probably know.
Yeah. I'm just rushing.
Yeah, sorry, I'm outside and sort of on the way, but yes, indeed, and I'm not a software engineer, but glad to be here.
Cool. You'll hear more from the Chorus team later, so maybe the intros are shorter. Ryan from Terra.
Hi guys, I'm Ryan. I'm currently a part of Terra to work on a project called Anchor, and for today I'll be presenting the set of requirements on the Terra side regarding the bridge, regarding the Substrate to IBC bridge, and very glad that you guys have organized this. Thank you very much.
It's a pleasure. Gregory Hill.
Hi, yeah, I'm with Dominic and Alexi, part of Interlay, focusing on PokerBTC. Looking forward to discussing more interoperability efforts.
Cool, thank you. Jake from Terra.
Hi, this is Jake from Terra. I'm currently building Anchor, which is a proof of stake DeFi for leveraging staking yields. Working with Ryan and Daniel. Happy to join this group. Thank you.
Daniel Hong. That's also from Terra, right? Yeah.
Hi, this is Daniel from Terra. I'm also working on Anchor. I'll be presenting on the technical stuff right after Ryan. And yeah, super great to see you all. Super great to be part of this group.
Thank you. Chris Goes. Of course, we all know Chris Goes, but yeah.
Hello, I'm Christopher. Most of you probably know me. I work at Interchain GmbH, the IBC development. So if you read the IBC spec and it doesn't make sense, it's probably my fault. Please file an issue. Continually encouraging people to do that. You would think they would, but sometimes they don't, so I have to plug it. It's fantastic to see everyone here.
Cool. Sean from Informal.
Yeah, I'm Sean, the CTO of Informal. We're working on specification, verification, and implementation of IBC, mostly on the Cosmos side.
Cool. And Alexi from Interlay.
Hi, yeah, Alexi here. I'm also from Interlay, and yeah, I've been focusing on cross-chain from PhD before, and then we co-founded Interlay, now working on PolkaBTC and also improving the cross-chain tooling around Bitcoin, Ethereum, and Polkadot. Yeah, glad to be here.
Cool. And I think finally we have Aidan from Snowfork.
Hey everyone, sorry I joined late. Yeah, I'm Aidan from Snowfork. We are a group that works on a bunch of interoperability stuff in the blockchain space. And at the moment we're working on a bridge between Ethereum and Substrate.
Cool. If I've missed anyone, please feel free to grab the mic and give your intro. Okay, looks like I've not. So maybe as the first topic, we can have a demo from Chorus 1. So we have Parth and Joe presenting. Maybe Parth can also give a short intro when he starts his presentation. But let's get on to it. Yeah, Joe.
Can everyone see my screen?
Yeah.
Excellent. That is good news. It's a good start, at least. So, Wormhole is a project that, of course, have been working on for the last few months, funded by a grant from the Web3 Foundation. This is phase 1 of the project, which, as we said, is a project to investigate the bridging of Cosmos and Substrate ecosystems. Now, it's easy to view Cosmos and Substrate as two disparate universes, so hence the name Wormhole is a bridge between those universes. The goals of the phase 1 of the project were reasonably simple. It was to build a proof of concept chain or proof of concept solution, validating or proving the validation of Substrate headers on a Cosmos SDK chain. So in April of this year, we released our initial report, including a dive into the is everyone seeing the same slide I am? Because I'm getting messages saying that they're not.
Still the title over here.
Okay, that's not helpful. Let me stop sharing and reshare. See if that helps. Apologies for that.
I'm seeing your mouse move, so you may not want to go into presentation mode. You can just kind of click the slides through.
Okay. I'll, is that better?
Yeah.
Is anyone seeing anything other than the main slide?
Yeah.
No, excellent. I was going to leave it there then. So yes, as I said, Wormhole is the name we've given to this project to bridge these two universes. For phase 1, our goals were to essentially build a proof of concept chain, proving that we can indeed validate Substrate headers on a Cosmos chain. And in April, we released our phase 1 report, or milestone run report, which detailed our chosen architecture using a CosmWasm-based module and a WASM compilable version of the Substrate Lite client, which was an idea that was initially proposed to us by Zaki. As part of this project, the implementation of the remaining elements of the IBC stack, so connections and channels and anything beyond the validation of those headers was out of scope. So we got started on the project, and then there was some interest from an outside party in the Wormhole project. So we did an internal hackathon, and as a result of those slight changes in scope, we're now delivering a bidirectional validation of headers between Cosmos and SDK. So it's validation of Cosmos headers on the Substrate side and validation of the Substrate headers on the Cosmos side. So what we have, some of these are already open sourced, some will be open sourced in the coming days, but a Cosmos SDK module based on CosmWasm by Ethan Simon. This is currently, it was implemented on top of, or as a submodule of IBC, although it doesn't actually use a lot of the existing IBC logic. As I said, it's out of scope for this project. But as a proof of concept, it was kind of useful to build on top of something that already existed. There's a Substrate Lite client. in Rust, which compiles down to WASM and is runnable within the Cosmos WASM runtime. We have a Cosmos SDK light client, also in Rust, which was based upon the Tendermint RS repo initially. That itself was at the time, at least at the time, was quite far from being compiled down to WASM. So we had to fork it and fork various parts of it to create our own library. Obviously, that original one was from Informal and others. And then Quantum Tunnel, which is a non-IBC compatible relayer, which just pushes or listens on WebSockets and pushes packets between the chains. Now, this is a diagram of which some portions of it were in the phase 1 report, but obviously it's been updated to handle both sides of the project now. So on the left-hand side, we have our substrate chain. We have the wormhole palette within the substrate chain. Consists of essentially some storage and some logic in the Tendermint light client. When the substrate chain creates or mints a block, or mints a finalized block, as designated by Grandpa, this subscription to the chain finalize headers API endpoint consumes that block. The WebSocket emits that block, that message, which is consumed by Quantum Tunnel, which then does some additional calls to get things like block hashes, block numbers, authority set data, and we bundle this into an SDK message. So the first block that gets emitted becomes a sort of create client message if we're using the Tendermint IBC parlance. And subsequent messages then are an update message, but it works in largely the same way. And that is submitted to the Cosmos SDK chain. Obviously gets picked up by the router, gets handled by the message handler in our new module. And that instantiates, the create message instantiates a WASM contract, which is a block of WASM that we've previously compiled and uploaded to the Cosmos WASM VM. The verification happens, and then obviously the state gets persisted into level DB. Now, obviously, that all happens within the minting of a block. So the same thing happens in the opposite direction. The block gets emitted by the Tendermint RP or WebSocket. That gets picked up and consumed by the relayer, which again does some more RPC requests to get things like validator set data. And then that gets built into a substrate extrinsic, which is a version of a transaction essentially. And that gets pushed again using RPC back to substrate for the next iteration. So it kind of goes around in an indefinite loop until things go wrong, or if things go wrong. They don't, hopefully. So some caveats and exceptions for phase 1. There's not currently a method that we've figured out or that we are aware exists elsewhere to prove non-immediate descendancy of substrate blocks. So this is obviously quite a big blocker to being production ready in that we currently have to prove each and every block in turn, which is obviously both expensive in compute and also in gas fees, because each one of these transactions need to be submitted by the relayer. And we can't miss a single block. So obviously, if we're comparing this to Cosmos IBC, we have the ability to only update our client on a periodic basis. We don't currently have that ability with the substrate verifier. This is something that we absolutely recognize needs solving before this is production ready. And there was also a conscious decision not to implement amino encoding of messages between the Rust relayer and the Cosmos SDK chain, simply because it's going to be deprecated very soon. So we currently use the LCD to submit the transactions as JSON. Obviously, any future work in this direction will incorporate protobuf encoding and submit them via the RPC. So that's essentially all I've got to say. I'm going to hand over to Parth to do the demonstration. Thank you, Parth.
Thank you, Joe. So, hey guys. So I'm Parth. I've been working at Chorus One and leading the IBC effort of the company. So right now, what we are going to do briefly is we are going to set up a relayer, set up 2 live chains, and set up monitoring window where we can see the status of the live client, and plus that is the happy flow. And in the second part, we are going to simulate one side of the chain and try to feed the invalid or malicious input to the live client and see it fail. So let me just share my screen. Can you guys see my screen? Yeah. Okay. Cool. So before we start setting up, let me describe all the components that are involved. One of them is like 2 of them are the 2 chains. One is the Cosmos chain, which contains the IBC module with Wasm embedded. We will install a Wasm blob as a part of setup process into that module. Second thing is second component is the substrate chain. Substrate chain with a custom palette called Tendermint client module, which embeds Tendermint client here based upon Tendermint RS. Third is the quantum tunnel. Quantum tunnel is a relayer that connects both chain and takes finalized header from substrate side as well as header from Cosmos side and send it to their respective live clients. Then on this side, the other 2 window consist of monitoring side for the Cosmos live client on the substrate chain. We are using Polka.ui to monitor the storage value, and on the substrate live client on Cosmos side, we have a small binary in Rust that just pings the RPC API exposed by the IBC Wasm module, and will keep displaying the JSON status of the live client. For the demo purpose, we made some changes in both of the chain. For example, on the substrate side, we have reduced the justification timing from default 512 blocks to 3 blocks, just so that we can show the that the justification is being processed by our live client on the Cosmos side. And in the quantum tunnel, we have made changes where instead of basically in production, if you are receiving error response from any live client, you need to continue or at least handle the error somewhat. But for the demo purpose, we are directly panicking upon if we are receiving any live client error on the quantum tunnel side, just to show you guys the exact error that it is terminating there. Regarding the live client's root of trust, first header received by quantum tunnel upon starting is used as a root of trust while creating the client on both sides, for Cosmos live client and Substrate live client both. Okay, so that was all the changes that we have made. And as Joe already said, we are using live client daemon to send transaction instead of directly connecting to Cosmos chain. So let's start the setting up. Let's start setting it up. So firstly, I'm going to start the Cosmos chain, which is in this window. And I'm now going to upload the substrate client.wasm file that I have on my local machine. So we have successfully uploaded the Wasm client there. Now on the substrate side, I'm going to first parse the data and then start the chain. Now first we will both chain will start. Basically, both chains will be live. We are going to use the live configuration in the quantum tunnel. So what I meant by live configuration is here, where we are connecting Cosmos with this and Substrate with this. So both of them are not simulated and are actually running on my local. Okay. So let's start with the live configuration. So after a period of time, you can see that on the Cosmos side, there is a client created. The last finalized header will be kept updating. On the Substrate side, we will see that what are the available client created, and we are saying that there is one client that is being created by quantum kernel. Due to technicality, I need to convert it to hash and then get the information on this side. So this is status of Cosmos Lite client running on Substrate chain, and this is the status of Substrate Lite client running on Cosmos chain, where you can see that it is finalizing blocks every third block is finalized, and the same is being updated here. And you can see the current authority said that it has ingested right now the best header that it has currently there. And in this side, the trusting period for the Cosmos headers, maximum clock drift allowed, unbonding period, and the last block that we see. So this is entirely is a happy flow. There is no invalid headers coming in because of course both of them are valid chain and running properly. So now we want to simulate a scenario where there is a malformed input to the live client, and we want to see that how it fails upon receipt of or does not accept that. So let's first start with Cosmos Lite client running on Substrate. For that, we will stop the quantum tunnel, and we want to start with simulation configuration for that. So for that, what we are going to do is we are going to open Cosmos Lite client simulation. So this is the simulation data containing of 4 blocks. One of them is 154. The other one is 174 block. Then the third one is 200, and the fourth one is 210. Now, what we are going to do right now, already did those changes. Okay. Let's just make some changes to the third block, which is 200 block. What I'm going to do is in this header there are 4 signatures from 4 validators. So what we are going to do is we are going to modify the validator address for those signatures. We are going to modify 2 of them. So now what should happen on the live client side is that when it ingests this header, it will recognize that out of 4 validator, only 2 correct validator has its signature, and 2 of them does not match, right? So only 50% of the trusted validator has signed the block. And since our live client imposes that at least 2/3 plus stake validator need to sign this, the live client should refuse to ingest this block, and that should be there printed. So for that purpose, we are going to stop the Cosmos side from this side, and we are going to start with simulation. Sorry. So once we start, there is another client ID created, as you can see. But in this case, so we have ingested 174, but it won't go above that because the 200 block that we that is there in the simulation data is invalid. Yeah. So it has failed on the quantum tunnel crashed because the data was invalid there. Now, if I correct those data, like for example, let's say if I undo this and if I start it again with the client needs to be created here, which is created. So we have ingested up till 210 block, which is the last block. It's not going to progress any further, but if we pass the valid block, it will accept. If we pass the block with not enough signature or any other error, it will reject. So this is the scenario where the Cosmos side was simulated. Now let's try a scenario where the substrate side is simulated. So in that case, we are going to reset this and going to start it again. Upload the boson block again. Succeeded. And we are going to take a look at. So this is the substrate live client simulation. So basically we have 7 number of blocks, as you can see, number 0x5, 0x6, 0x7. And out of these, the 6th block and the 3rd block has the justification. Now, what we will do simply is we will change the set ID. No, not instead of changing the set ID. Let's make the justification invalid first on this side. So I just change the byte in the justification, and now when I start this, so this window. So now, into this simulation, we'll be able to see that this client ID is created, the base header as it 1, 2. But now it will fail because we have changed the justification on the 3rd side. And yeah, so the error is, we have crashed, relay is crashed, and the error is justification is invalid or authority set is not updated, which is exactly what we did. Now, if I undo this, so I undo this justification error, and if I restart this one, there will be another client will be created, right? And this client will go all the way to 7 header, with the 6th header being the last finalized header. So your third header as a last finalized header, not 4. And at the 6th, and the 7th. Okay, so the last finalized header hash that is here is the exact same header hash that we here, which is parent hash of 7th header hash of this. Okay. So yeah, that was it. We did all the, like, at least both the part wherein in first part we had a live chain, in the second part there was a simulation data and how the light line differentiate between valid and invalid.
Cool. Thanks, Parth. Maybe quick questions for 3 or 4 minutes, and then we move on to Terra. Any questions?
I mean, the obvious one is, so what's the difficulty you're having with Ancestry? You need Ancestry to implement a grandpa light client in the first place. So it's not clear why you'd be restricted to importing every block.
So our difficulty with implementing, like with skipping the blocks, was that what we wanted to do is, let's say for example, the ancestry, the finalized ancestry that is coming from the coming from the relay. First of all, we aren't trusting it. So if the relay send us X header and then after Y header, then there needs to be a way so that we can verify that X and Y both, like X is the ascendant of Y. We need to verify that that was the first difficulty. To do that, so I know that there is another way where we can do this, which is where we need to request justification for every block we receive and ignore the block that we don't receive justification for. So if I receive justification for both X and Y, I don't need to check that ancestry as strictly as possible. But since due to the trustless scenario and due to,
I mean, for one thing, I'm not sure if we actually get justification for every block.
yeah,
or whether we can skip
aren't. So that's why, so we are not skipping them. So what happened right now was that we have a 7 block, right? And the third and 6th block had a justification. So up until the 3rd block, we recorded the first 2 blocks, but we didn't mark them as the finalized. When we received the 3rd block and we figured out that yes, this justification is valid, it refers to the correct header, which is the 3rd header. And then we marked the 3rd header as a certificate, 3rd header as this one. And by that relation, we also marked the 2nd and 1st header as also finalized, because it was clearly proven that the 2nd header was ancestor of 3rd and 1st is ancestor of 2nd. But now let's say if I send only the 1st and 3rd, and I don't give you the justification for 1st and only give justification for 3rd, there is no link from 3rd to 1st, and I don't know how I can how should I how can I trust the 1st header? How can I consider it as a as a finalized header?
Yes, but in general, you might need to, in order even to get a justification for the 3rd header, you might need to put in a 4th and a 5th header in.
Yeah.
This is usual. So what's the difference in between this and putting a thing which goes from 1 to 3? If you're already doing from 3 to 5 anyway, or from 1 to 3 in justification of 1, why is it harder to do 1 to 3 and 3 to 5 in to just put the justification of 3 in?
Can you describe it like little better? So from my only dilemma that while implementing this was that how can I trust the first header? I know that what you are saying that while
Right. But the point is that you, in order to even prove that the first header was justified, you might have needed to include the second header.
Yeah, but no, but for example, let's say for the third header, the justification will contain the third header, fourth header, and fifth header, right? So it will contain those fourth and fifth header, and I mark the third header as a finalized one. But since on my local database, I know for sure that third header is a third header is a child of second, and second is child of first. It can be established that since third is finalized, first and second is also finalized too. Right?
Yeah.
So if I skip the second header, how will I be able to prove?
You put the third header on first with its justification, and then you can put the first and second headers. Since now it's clear that they're ancestors of the third one, right?
So yeah, so you are just saying that I need to pass the header in reverse formation. So I pass the third header first. We verify that the justification is valid and points to third header, and then I pass the second and first header as the ascendant of the third header. This is what I'm saying.
That would be the obvious thing to do, right? So I mean, at the moment with Grandpa, we have sessions. We can tell when the keys are going to change every 4 hours, which should make working out what the authority set is easy. We're going to change that to, we're going to have some keys that are going to stick around for a day at some point in the future.
Yeah, I think this approach makes sense. Sorry, but like I just didn't think about this earlier.
So what would be the overall consequence of that approach? We would be able to basically skip to just verifying all the justifications. And do we still need, so is it the case that justification 3 is verified and we still need to verify headers of 2 and 1, or can we just skip verification of 2 and 1?
So I think what he's trying to tell, as far as I understood, is that in this scenario, right? If I implemented it that way, what I would need to do is I would need to pass the third header first, and I will verify that I will verify the justification and see that the third header is finalized. Now, after that, you can, or you, like, depending upon the application, it isn't necessary that I need to pass the second and first header. But if I pass it, and we can then, like, after verifying the third header, we can pass the second and first header, and since we can verify that third header was child of second header and second header was child of first header, we can mark first and second also as finalized.
Yeah. Other questions?
I would be curious about learning about the kind of computational overhead of verification of these headers on either side. So imagine we're going the approach that Alistair outlined, which means that we basically just verify justifications, and basically, I assume you only have to do that like at least once per session. So you can at least follow the changes for the validator set or authority set. But then if you have any block in that session, do you need to follow the chain of blocks in order to verify that that block was in session, or is it enough from a security standpoint to just assume that it's signed by the correct validator set or authority set, and there's a justification for a newer block with a higher block number, so we just assume that it's a correct block? Is that enough, or is there something I'm missing?
So
in terms of
clearly not,
security?
right? At the moment, the only way of doing it is to put back the header chain. We need to push back the hash chain to the header in question. Otherwise, we may be looking at ways to speed this up. By looking at Merkle mountain ranges or point number commitments. I think that's definitely on the agenda to look at ways to speed this up. But at the moment, the only way of doing it is including the hash chain back to the header you want to show is correct.
And the reason for that is that the authority set could also sign a block that's not put on chain, but that's just sent over that bridge or over.
No, what I mean. So what do you do? So if we just verify, if we have a justification for the last block in the session, and we see a header that's theoretically for a block earlier, then what do we do?
I mean, we could create economic incentives for the authority sets. So if I have that signed header, I can maybe have some logic on chain that is slashing the authority set if they signed it, but it's not in the canonical chain, in the finalized chain up to that point, right? So I think I'm just thinking, is it needed to follow the chain, which is quite expensive?
So if you have justifications for all the things for all the blocks, so if we have block justifications for multiple blocks, you don't need to follow the chain. You need to go back from some block you have justification for to the block you care about, right?
Yeah. Okay.
And yes, it could be cheaper. It should be. It depends. Did Tomac? Did we ever get the hash chain change we wanted to do, where you didn't have to include all headers to follow the hashes back?
No, I don't recall anything like this.
Because I discussed that with Rob a long time ago.
But then my question would be that if I have to anyway follow the entire header chain, then the approach that I did right now and the approach that you are suggesting, what would be the advantage in case where I ingest the third header first and then establish the relation to the first header, since I anyway need to ingest the second and first header in both the cases.
Okay, sorry, I didn't get that.
Yeah, so what I'm saying is that like right now in this case, what I'm doing is I'm ingesting the first header, storing it. I'm ingesting the second header. And when I ingest the third header with the justification, I'm finalizing it and finalizing all the ascendant of it, which is second and one. Now, if I receive the third header, if I validate it, but I will still need the second and first header to finalize the first header. I cannot skip any data or I cannot skip any computation. So my question is, what is the advantage of doing it this way compared to the way that I have done like in the demo?
Compared to not putting every block on. I mean, so your relayer still has to have all these headers, but you don't necessarily need to put all of them on the chain, right? Only if you need them to prove something.
Oh, yeah.
That makes sense. Yeah.
That makes sense. So you are saying that, so let me understand this correctly. So for example, I'm at 100th block. 100th block is with the justification, and in my scenario, I will need all the headers from 1 to 100, and then I will mark all of them as a finalized. But for example, let's say I only need the header number 80 to prove something. Then in your scenario, I can just get the header from 100 to 80 and mark 80 as finalized, and I'm done. I don't need.
Yes, that's correct. We should definitely be looking at ways to skip more in Substrate. That's been on the cards for a very long time. So one day it'll be easier, but right now, that's what you have to do.
Something along the line of how, I'm not sure if the same thing you can do, but something along the line of how Cosmos Live Client does. So basically what Cosmos Live Client does is it has, let's say for example, there is a trusted root which has n number of validator or the authorities have signed this block. And now if I pass a header, let's say after it's n plus 100, it will check if the authority set that has signed this header and the previous trusted authority set who has signed the root of trust, what is the intersection between them? If it is majority plus, basically this is the scenario where you can set it, but for the security perspective, majority plus, I think 2/3 plus state authority, if they have signed, then it will also trust this. And the trust chain, you can go, if I can pass n plus 100, n plus 200, then it will go so and so forth.
But that needs some economic mechanism for slashing, right? Because the authority or the validator set could still like produce valid blocks on chain, but then just produce secondary Byzantine blocks that they don't put on chain, so they don't get slashed for them, but send to your bridge.
Well,
So,
I think usually that slashing would happen on the main chain. So, for example, even though the bridge gets fooled, the validators get slashed on Cosmos itself because they've created 2 different blocks.
That's correct.
Yeah, you're right. So every user could basically like submit that Byzantine block to have them slashed. So you don't need to implement anything.
And absolutely
Yeah,
the
that
same
makes
thing should at some point be the case on Polkadot. If you finalize something on a different chain, then the validator set should be on the hook.
The only kind of, I think, risk there is, imagine the validator set doesn't change for 100 blocks, and then 2 people rotate out and some new blocks are created, and then a week later those same 2 people rotate back in, and so the validator set in January is the same as the validator set in February, but between the 2 periods of times it's changed a lot. Would the bridge be able to detect that kind of change?
I think if you're talking about Cosmos side, Cosmos light client side, there is a way that every time the I think this is something that
Side, you're still, even if you're not validating, you're still bonded for 21 days, which is more than 2 weeks. So you can still be slashed.
Yeah, so that kind of attack, there's like a 21-day window during which it is protected.
Yeah. And so essentially there's like, what you were talking about before, Parth, was like, how can you trust a new validator set? Well, it depends like when were they validating, when they were bonding, and then plus this other criteria, which is like, if they were to perform some kind of attack, whether it's amnesia or equivocation or whatever, how much time does it take us to figure it out? Which is like essentially how long it takes for fork accountability protocol to go through. So all that time is like how long you could trust a validator set.
makes sense. Any other questions? Feedback? Anything?
Yeah, a quick question for you just on the roadmap here. Can you talk about the upcoming milestones?
Okay. So right now what we are planning to do, the immediate thing on our radar is polish quantum tunnel little bit, figuring out, and then open source it. Open source the wormhole part, which is the substrate palace and everything. After that, it depends upon various external factors. I think Meher can talk more about it.
So like the roadmap thereafter, like until now we've been only funded to do at least like half of this work that we have done, and right now kind of we are working out how to sort of secure funding for the next pieces. But from our perspective, the interesting roadmap would be that there are a few customer organizations for this work, and we see at least two of them. One is Terra and one is Band. So both organizations are on this on the call. And to us, the interesting problem statement would be to basically define their needs and try to build like the bridge in a way that to build components of the minimal components of the IBC stack that are needed to satisfy their requirements. Now, maybe their requirements are so deep that we need to implement all of IBC. So the part we want to analyze right now is for these organizations, what is exactly their set of requirements, and what does it mean for us for the implementation of IBC? Because the main challenge now is the implementation of IBC inside Substrate. And the main questions that arise are, what pieces do we need to prioritize? And if there are any interface questions, right? Like how does IBC interface with the other Substrate palettes? So I think the next stages would be kind of analysis of customer requirements, analysis of how we'll build IBC inside Substrate, and then execute on that project. And part of the reason why we are building this working group is, these questions are very interesting, and they require the collaboration of these various teams, because they have to come with different requirements. And it's also the case that while building IBC in Substrate, there's informal systems that's building IBC handlers in Rust. So how can we leverage that work into our work? That's an interesting question. There's also the C-Dot team that's doing something very similar. They want to build substrate to substrate communication using IBC. So how do we leverage their work? And so right now we are in this phase where we want to understand where these teams are at and then design our path forward. What we would like to achieve is to enable these customer organizations to be able to use a bridge sometime a few months downstream.
One question, Polkadot's consensus algorithm is being kind of updated, and I haven't been tracking changes to that closely. Do you have a sense of the direction there, how much work it would take to make those updates, and kind of planned work for potentially making them? I think you're muted, Alistair.
Polkadot's consensus algorithm, so the basic part is not being changed, but we might be adding extra things which would help. So all the code that Chorus One currently has is going to be carrying on working. As far as Web3 is concerned, we want to see IBC on Polkadot. In particular with parachains and things, when that's a thing. But other people might need it earlier.
Right. So I think the earliest use could be that even there's a standalone substrate chain connecting to a standalone Cosmos SDK chain, and then as parachains drop into Polkadot and XCMP drops into Polkadot, then it'll be interesting to run our work as a parachain and have a bridge to the Cosmos SDK ecosystem. But that's probably the kind of question that becomes material a few months later again.
Seems like we're going to maybe shift over to conversation with Tara in a moment. Maybe prior to that, after meeting with Band recently, my understanding is that they're running a different WASM virtual machine. I'm not totally sure how your work translates to their context. Obviously, it's still WASM, but have you touched base on that at all?
I don't think we talked yet, but our WASM is a completely different concept. I guess what we are interested in the most is the way we can relay data from Cosmos to Substrate. So basically, kind of like one-way bridge. so we can supply Oracle data to as a palette, for the Substrate blockchain, right? I mean, full IBC would be nice. So message can be sent, and then like people don't need to know about how message gets sent except the relay layer. But I guess initially what would be useful to us is the way you can continuously supplying the block header of Cosmos chain on Substrate, I think, which is already demo. And also the way you can verify that something is actually in the Cosmos chain. Basically, iterate through the multi-store and then iterate through the IAVL tree, and that proof, verify that something on band chain, on the Cosmos chain, is actually in there, and pilot on Substrate can verify, if that makes sense. Yeah, don't worry too much about the what's in runtime. I think it's not relevant to the work here.
Okay. So we've actually run out of time today. We had Ryan and SH from Terra lined up to present on their requirements from the bridge. Since we're out of time, that will be done next Tuesday. I'm sorry, Ryan and SH, wasn't aware it will take that much time. So let's close the call now, and I look forward to meeting you all next week and going through some of Terra's requirements, and if time remains, then C-Dot's demo. So maybe we'll take a few weeks to get the current state of the different teams, and then have richer conversations after that. So I look forward to catching you all next week.
Bye. Cheers, guys. Thanks.
Thank you, everyone.
Bye bye.
Oh.
Cheers. Thanks, guys. Bye.
Thank you. Bye.